All right, well, welcome everybody. I'm glad you could come in today, and welcome to our parents who are at home watching this presentation also. Or at work, absolutely. And I'll just say this at the beginning, if people have questions, anything that you'd like me to talk about a little bit more or stop and go over, please feel free to ask, no problem. So we're going to talk about why bar models are such a powerful tool. We'll talk about what are bar models, we'll talk about the purpose of bar models, and we'll talk about some advantages of bar models. All right, so first of all, at the junior school, we teach them in grades 2 through 5. And the reason that they are so powerful, it's a very systematic visual way to take a very complex word problem and turn it into something that is understandable by children, to do the math part. And the goal actually is to give students another strategy to solve word problems. We all grew up with different strategies. And we were all told, oh, do this way by certain teachers. But sometimes children don't even know where to begin. And this is just another tool that they can, or another strategy they can put in their toolbox. And it's very powerful because it's visual. And the idea is the more times they solve these types of visual problems and have a visual representation, then hopefully eventually they'll have a mental representation in their heads also, so that eventually they may not need to draw a bar model. They'll just be able to visualize it in their head. All right. Also, it avoids the common issue of not knowing where to start. I have plenty of students who say, I don't know, I don't understand, I have no idea. And I remember, hi, welcome. And I remember myself growing up, you may remember teachers would try to teach you some tricks. Look for certain words, all together, in all, difference, more than. And that was fine if there were two elements, but as soon as you threw in something else where there may be more than one step in the problem, or more than one operation, you know, for me, I know I was kind of done. Draw a picture. I didn't know how to draw a picture. Those strategies were not always taught. So this is a great way for kids to just add another strategy to their toolbox. Some children will need, a lot of children need it, is what I found, and then some children may not need it because they already know how to solve the problem. But again, it's just one more strategy we want to give children to give them a boost in solving word problems. Okay. Advantages of bar models. Children can solve simple problems as young as 2nd grade, and actually I'm going to start with a 2nd grade problem today, and you'll have to let me know if you think it's simple. And also complex word problems that sometimes have anywhere between 2 and 5 steps. All operations could be involved in this word problem, for everything from addition to division, multiplication, subtraction. It develops algebraic thinking. We're going to talk about some of the problems today actually could be solved algebraically, but children here you don't need to know algebra. It's a precursor, pre-algebra, so to get that visual model again in their head of what it should look like, so when they're shown the algorithm, it makes sense. It follows the introduction of operational skills. So the mathematical part that they'd be using to solve the problem, those are things that the children would have already been taught. It helps visualize the part-whole structure of a problem. What exactly are they being asked to solve? Is it the part? Is it the whole? Which part? And this model will help students quite a bit in that area. And it develops operational sense. Because sometimes students have difficulty figuring out, do I add, subtract, multiply? What do I do? The model will help them do that. Now, bar modeling is not a method of calculation. It's actually a pictorial approach. It helps them actually decide what operation to use. So when we practice today, I think you'll see that a little bit more. It's very pictorial. Once it's constructed, then the children can go on and complete what we call the abstract part, which is actually the calculation. So it's really helping them get through different phases to actually get to the calculation part. All right. Any questions so far? All right, we're moving on. All right, we're going to go over bar model steps. And in your packet that you have in front of you, and I think people were sent that at home also, there are 7 steps. And this is actually what I have in my classroom. Students get copies of these steps. And if you follow these 7 steps systematically, you will be able to create a bar model and actually complete the computation. So we are going to go and use these 7 steps as we complete our own bar models in this session. And you have it in front of you. So, all right. So now what I'm going to do is, okay, I'm going to switch to my ladybug. All right. So let's close this out. All right. That's my dog Carly, if anyone really cares. She's my girl, my 3rd child. Okay, so now, all right, so everybody has the bar model steps. They have a packet with bar model steps. And you should also have a packet right beneath that, and we can go over that later. These are just helpful hints. It's a model drawing reference sheet that can give you tips for solving addition problems, subtraction problems, division problems, multiplication problems. And it gives you some hints as to, for example, if you're doing subtraction, you're going to want to draw a longer bar because you're going to be taking away things. Addition, you might want the unit bars to be smaller. All right. And using squares and rectangles to represent parts of the problem. So I'm going to actually demonstrate the first problem to you, and then you'll see on the second page, we're going to try it on our own, see how we do. Of course, with assistance. All right, so let me get this set up. Okay, is that clear enough? Can you see that? How's that? Okay. And I did it on graph paper because it works really nicely for drawing rectangles. Okay, so the first step is we read the problem. Normally in class, I would have students read it aloud. So that's what I'm going to do, assuming we're in class. So Linda had 48 flowers. Chris has 25 more flowers than Linda. How many flowers do Linda and Chris have altogether? Now, as a side note, I showed this problem initially to my husband. He solved it wrong. He's really good at math too, because he saw the word altogether and he assumed, oh, just add 48 and 25 up. This is actually a 2nd grade problem. So let's go through and see how the bar model can actually make it easier for a student who maybe doesn't know where to begin or doesn't know sort of where to put all the parts. So we read the problem. Now we're going to identify and write the who and the what. So who is in the problem? We actually have 2 who's, because we have 2 different names. We count them as 2 separate who's, Linda and Chris. So I'm going to write here, and I start on the far left. Organization is really important in bar models because we want everything to sort of work from the top down so that students can actually understand what they wrote and see their thinking on paper. So I'm going to write, now the who and the what. The what is flowers. So Linda has flowers, Chris has flowers. So I'm going to start with Linda's flowers. And I'm going to skip a line, and I'm going to put Chris's flowers. Okay. Now, the next thing to do, we're going to step 3. We're going to reread the problem. So what's nice about this whole system is that the kids are constantly rereading the problem and not just reading it once and kind of whipping through it. They're not, otherwise you might miss some important items. So I'm going to go back and do it again. Linda had 48 flowers. Chris has 25 more flowers than Linda. How many flowers do Linda and Chris have altogether? Now I'm going to draw the bar. And what that means, I want to draw something to represent any number. So anytime, I always tell my students, anytime I see a number, it has to be represented in the problem. But we're going to draw our bar first. And so we're going to chunk this, and we're going to take it sentence by sentence. And I always start at the very beginning and work to the end. So we're going to start with Linda has 48 flowers. So I'm going to draw a bar for Linda to represent 48 flowers. And what's nice is I can adjust it later if I find it's too large. So I'm just going to do something like this. Now it says Chris has 25 more flowers than Linda. Well, that also students from experience would know that Chris has to have at least 48 flowers. So now I'm going to actually add on to his bar. So I like to do is draw a bar the same size as Linda, because Chris has at least 48, the same amount, right? And then it says 25 more flowers than Linda. So now I'm going to add on a bar to show the 25. Now, because I know this is 48, and I kind of want to do it to make it proportional, I might go about halfway. Something like that, or a little further. And I also want to put my numbers in. So students usually put the numbers on top, so that represents 48. I don't need to write the word flowers again because I already have it on the side. And it says Chris has 25 more flowers than Linda, so that's another number I need to have. Any numbers need to go into your bar. So 25. Now sometimes students will like to put dotted lines here to indicate that this bar, that Linda's bar, is the same size as Chris's bar. All right. So now we've done the drawing the bar, we've put in the numbers. Step 5 is label the bar. Question mark is really important because that gets to the last sentence, the question that we're trying to answer. How many flowers do Linda and Chris have all together? And you'll notice that there's a bracket and then a question mark. And sometimes after you put that question, the kids see immediately what to do. So all together, how much do they have all together? I'm going to put my bracket on the outside and then put my question mark here to represent that I need to know how much all those units equal in total. Okay. All right, have I done everything? So I'm on step 5. So number 6 now, I'm going to the abstract part of my problem, and I'm going to be completing the computation. Because it's commutative property of addition, there are multiple ways to solve this. And this is what's interesting too, is that there's not just one way to do the computation, and sometimes there's not one way just to do a bar model either. So when we present them in class, you'll see all kinds of different interesting ways kids do them. I might just start this way, and I like to number them, so I'm like step 1. I might do Chris's flowers. How much does he have? And students would know this operation already. So we know it's 48 plus 25. So 73. Now that I know that this whole thing is worth 73, I can add in Linda's flowers fairly easily. So I now can figure out the total flowers. So I can do 73 plus 48. All right. So I've done the computation part, and then we always ask students part number 7 to write the answer in a complete sentence to show that in their mind did they actually answer the question. Because sometimes we forget about the question when we're doing all these different other labeling of parts and putting the question mark. So I'm going to actually write this in a complete sentence. Linda and Chris have 121 flowers altogether. And there's the whole bar model. And this would be a great example of what a second grader could solve. But can you see the difficulty that a child might have if they miss that Chris has 20 more flowers than Linda? And they're going to say, well, how much does, what does that mean? How much does Chris have to start with? The bar makes it so clear that Chris is starting also with 48, and he adds on 25. And as students get more exposed, this model would disappear and be replaced by more complex problems. Anybody have any questions?
I do.
Oh, good.
Sometimes when I see the kids doing their homework, like, Lucy will put 4 circles, and then she'll go 1, 2, 3, 4, 5, 6, 7, 8, when doing math or multiplication or division. So when we're teaching this to them, are we teaching it, I feel like it's, if I were to give this to my child, right? Mm-hmm. Or any of them, actually, they would just take a 48, and then they would write a 48 underneath them, and then they would add, so rather than taking Chris's flowers and Linda's flowers and adding them together, they would add the 48 plus the 48 plus the 25.
And without a bar?
With the bar.
One step as opposed to 2.
Right.
Yeah, you could do it. And so right. I don't have to do it in 2 steps. I could, and the reason sometimes students are not I found adding 3 numbers together lends itself more to the probability that you're going to get an error, so I don't always encourage that, to be honest. But yes, if someone could do 48, even if they knew multiplication, I could do 48 plus 25. I could do 48 times 2.
Right.
And then, so there's multiple ways to do the computation. That's why I love to have children present them, because we're going to learn some kind of new way that I didn't think of before.
Okay, so it would be marked correct.
Absolutely.
If they did 48 plus
As long as they showed their thinking and how they got to that final, absolutely. I mean, as I said, there's like, here's one way, here's another way, here's another way, and then I could add in, the extra 25 here, right?
It's usually hard for the people on the website to hear the questions. So
Oh, if I could say them. Okay, so the question was, is there only one way that they are going to be allowed to do the mathematics portion, to actually do the computation? There are multiple ways. So I did it this way. Someone else might add up all 3 numbers. Someone else, if they're really advanced in 2nd grade and they know how to multiply 2 digits times 1 digit, they might do it this way. Right?
And in our classes, we'll talk about that. We'll say, does anyone have another way they did it?
Right.
Another way to do it? Because we're always looking for
Right.
efficiencies. And sometimes children, let's say it was like 4 people who had flowers, then they will try to do it, like it'll take a longer time.
Right.
So we talk about, this way seems a little faster.
Right. So you want to expose children to as many strategies, even in the computation part, as we can, because as Mrs. Sanderson said, there are more efficient ways. Whether they choose to use that in the future is up to them.
I have a question too. Now, since we're talking about different ways to solve a problem, now I understand that they have to use the bar model. What if they can find the answer without the bar model? Is it a must to use the bar model to get to the answer?
I think what we are, so no, not always. It depends on, I think we're trying to encourage children to actually almost put this into muscle memory. So I know, for example, there's some problems I do want them to do using a bar model that I know are more complex. And I know there's some problems that I would never ask them to do a bar model on. For a 2nd grader, I would ask them to do a bar model on this, frankly. If they were in 3rd or 4th grade, probably not. So it depends. Again, it's just another strategy from their toolbox that they can pull out, especially when a child has no idea where to start. And they need a visual representation, because this really clearly shows you what the problem means. And it's a very powerful tool for children to realize that. You're welcome. All right, so we're going to go on to one more, and this actually is your turn. But we'll be there to help. And those people at work or at home, if you could try this also. Oops. I think I'll have to rip this apart a little bit. So try it on your own. On Tuesday, the bakers, I'm just going to read it aloud, and then you can try to solve it. On Tuesday, the bakers made 40 loaves of bread. On Wednesday, they made 15 more loaves of bread than they made on Tuesday. How many loaves of bread did they make on Tuesday and Wednesday altogether? Now, just the amount of words could be confusing to a child. And let me know if you need any help.
It's really hard. Like, these are hard questions for a 2nd grade.
Oh, yeah.
I think so. Like, I don't think I could have solved this in 2nd grade.
Come on, mind.
Again, they would have built up to this also. So they would have been working with Unifix cubes and very concrete representations in the younger grades.
it's always harder for the kids that can do math in their head too, because they don't want to draw it out.
Yeah, so if you follow your 7 steps,
What are they asking?
so does everyone have their 7 steps in front of them? Then you won't forget anything.
Here, use this one. Yeah. A little easier.
I read the problem.
All right, I'm going to do the Mindy approach, and I'm going to add all of it together.
It's just so much easier.
But you'd be
I
amazed
know.
at the mistakes with 3
Yeah.
add-ins versus 2.
They won't be able to figure it out. I mean, I know Lucy would not be able to. She screams at me that I don't know how to do this.
Well, now
You're going to be an expert when we are done.
We'll walk out of here and know how to.
You're going to be pro bar model. Okay. Oh, yeah. Like that, okay. All right, everyone doing well?
I'm checking.
Don't forget your sentence.
Oh, okay.
The baker's made a total of something loaves of bread Tuesday and Wednesday. I didn't want to.
You don't want to blurt, and I think that's great. You're a good student. Not blurting out the answer yet. Okay. All right. So I'm going to show you my answer and compare it to your own. And what I'm curious about is your computation also. Okay. All right. So let's check it off. Did you write the who and the what? Tuesday's bread, Wednesday's bread. You could also put the baker's bread on Tuesday, baker's bread on Wednesday. There's various ways to do that. But you definitely need a Tuesday and a Wednesday in bread. Did you draw a bar that are about the same size and label it, the first one with 40 loaves, because that's what the bakers baked on Tuesday. On Wednesday, they baked this, they had to bake at least 40, but they baked 15 more, and then I added on 15. Do you have the 15 labeled? Mm-hmm. Do you have a bracket with a question to indicate how many loaves did they make altogether? All right. Now, this was my computation. You might have all done it. Maybe you added all in 40. Maybe you did it 40 plus 40. Who did 40 and 40 and 15? Did anyone do 40 plus 15 and then add 40? Did anyone do 40 times 2 plus 15? All right, we're moving on. Then a sentence. The bakers made 95 loaves of bread on Tuesday and Wednesday. Okay, everyone comfortable with this? All right, should we move to third grade? All right. All right. So we're going to move on. Okay, and we're just going to follow the same. Now, what's nice also, you know how sometimes I remember growing up, you'd have like 5 problems and they'd all be the same process. And you'd exactly add the same 2 numbers together, or 2 numbers together, and you knew that was like every 4 board problems in a row. This, we're really trying to, to challenge children to say that all these problems can be different, but you can apply the same strategy to these problems and be just as successful. So when we go on to the next problem, this is a typical third grade problem. Lindsay had 3 times as much money as Danny. If they had $40 altogether, how much money did Lindsay have? This is
I think it's important to point out, Mrs. Budd, that
Yes.
the third graders have not had algebra
Yes.
in their teaching so far. So I don't want to see anybody using X or
Yes. And
D. Yeah, so just remember that our
Yes.
kids have not had algebra.
please don't write down 40 equals 4x, and because actually you can solve this algebraically.
Right.
And I did actually, because I did it multiple ways, and I did it also with 40 equals 4x, and I went through all that. But let's say a child doesn't know, because actually this is a perfect algebra, pre-algebra problem. But they don't need to know algebra. That's what's so great about using the bar model. So I'm going to start again with the who and the what. All right, so I'm going to put Lindsay had 3 times as much money as Danny. If they have $40 altogether, how much money did Lindsay have? So we know the who has to be Lindsay, and it's Lindsay's money. That's the what. And also Danny. So Danny's money. Okay. Now, what's interesting here, Lindsay has 3 times as much as Danny. So Danny is going to start off with 1 unit. And when we're adding on, so he's going to have 1 unit as opposed to Lindsay, who should have 3 times as much. So she needs to have 3 units. And if you wanted to talk more advanced, you could also talk about ratios. That's a 3-to-1 ratio. And what we're saying here also is that one of Lindsay's units equals the one of Danny's. Okay, so let's go back and put in our numbers. We did the 3 times. If they had $40 all together, how much money did Lindsay have? So that's where my bracket, they have $40 all together. So this is interesting. What you can do is you can put the $40 on the outside to indicate that all these units equal $40. Now the question mark, how much money did Lindsay have?
It's very confusing.
So you'll see, we'll get you through. So the idea is a question mark, how much money does Lindsay have? So these are her 3 units. So this is where our question mark will go. Because that's what we're trying to figure out. We're trying to solve these 3 units. Now, what students will realize is that, and we talk about, these units are all equal to each other, and that's why it's really important that you actually draw them almost equal size. If all of them are worth $40, can I figure out what 1 unit is equal to? So on these kinds of problems, I'm going to think 1 unit equals something. And here's how I'm going to calculate it. 1 unit, if everything is $40, divided by, because these are all equal to each other, divided by 4. That means each unit has to be $10. Does it make it clearer now what Lindsay's money is? And then I would say, so this is my first step. I like to just do things in steps. And then I'm going to now figure out Lindsay's. 3 units equals $10 times 3, which equals $30. Okay. Did that make sense to everybody?
I don't know how to verbalize a math problem.
Does this helpful though?
We always use the phrase unit. So a unit is really your X.
Right.
As an algebra
So-
student, right? So we'll say 4 units.
This is a unit.
$40.
Right. So on these kind of, right. So we want to get 1 unit, and then actually that will help us figure out what everybody has. So I've already figured out that Lindsay has $30. So I'm going to say Lindsay has $30. Now, for someone more advanced, and maybe the bar, and if you're going to do it algebraically, I would say something about 40 equals, 4x, right? And then 40 divided by 4 equals x, which equals 10, right? And then 3 times 10, because I'm talking about Lindsay, equals 30. So this is a pretty sophisticated problem that we're asking a 3rd grader to solve without having any knowledge of algebra.
So really that second part is the goal eventually. What we're doing is making their minds start thinking about in units and really making those connections in the brain so that when they're in 4th or 5th grade, they get to that,
Right.
The algebraic form. Yeah.
And then when they actually start solving algebra, they'll have a mental representation of what it could look like.
Once you figure out that 1 unit is 10, can you take your 10 and can you put it in each square?
Yeah, absolutely. I could write, if it's easier, more visual for you, so the question was, could I write 10 in each square? Yes. If that's more visual for you, you can do that. Absolutely, there's no rule against that. You could add all kinds of things in there.
The tricky part to this question too is what are they asking for?
Yeah.
Right.
Because you have to know where your question mark goes.
Right.
And that's a little trickier.
Right. So I'm going to ask you to turn to the next page, and I'm going to ask you to try it on your own.
We have one question.
Oh, great.
How would the teacher handle an answer if a child showed their work in units and bars and arrived at the same answer, but didn't realize they were using division or multiplication to arrive at it? For instance, they just got it without realizing exactly how after seeing the bars.
So they just arrived at the answer, but they can't explain how they got it. I think it would be really important for the student because we need students to be able to explain their thinking. And so we'd probably ask the student to be listening to how other people solved it. Because sometimes it's a matter of just being open to other models that are out there and other ideas that people have. So I would probably still ask the student to explain their thinking, even if they couldn't use it, do it through a bar model.
Especially in third grade where we're just starting.
Right. All right, so this one is try it on your own. Mrs. Budd drove 98 miles on her vacation this year.
No, Alex and Lance pencils. You skipped two.
No, I apologize. I think that you can't use that problem.
You can't because
No,
it's 70, it has
no.
to be 80.
All right, so you know what? Let's move on.
Switch it to 80?
I don't have that problem in my packet.
Oh,
I think it would be 90.
oh, would it be 90?
Okay, I need a packet.
Four.
Okay, yeah.
All right, well, everybody, here we go. We're gonna switch. You have to switch this. Are we switching it to 90? Because that's, I think, why I took it out. 80. So let's make this, instead of 70, we're gonna make this 80. All right, so that's the one everyone has in their packet, right? All right, try it on your own. Again, try to stick to those 7 steps, because I found once you skip a step, there's a high risk of error. I'm just solving as you're solving it since I didn't do this problem yet.
Question.
Okay. All right, so take a look, and this is how I did my problem. You might have a different calculation. Does it look similar to yours? Do you have the who and the what? Lance's pencils, Alex's pencils. Do you have a 3-to-1 ratio, 3 units to 1 unit? Do you have the bracket to indicate that all 4 of those units is equal to 80? 80 pencils. And then I need to figure out what 1 unit is, assuming that all 4 units equals 80, each unit is equal to each other. So I do 80 divided by 4 equals 20, and that's the 1 unit. And because I'm only looking at Alex, who only has 1 unit, Alex has 20 pencils. Right? All right, any questions? It is. But you'd be surprised how quick they can do it. It doesn't take as much time. Okay, let's move on to 4th grade. All right. All right, and this problem we're doing a unit on fractions right now, and we're going to be going over these kinds of problems beginning of next week. In fact, this is one of the problems that we're going to do in 4th grade. This is a classic problem. We're actually multiplying by fractions. So Eva had $50. She used 3/5 of it to buy a jacket. How much money does she have left? So a lot of us, I know I was just taught the algorithm. You multiply the numerators and you multiply the denominators. But in this case, students don't have an understanding of multiplication of fractions. So how can we use a bar model as a powerful tool to actually solve this? So I'm going to start the same way as I always start. I read the problem. I'm now the who and what. So I know it's just, there's only one who. So it's Eva's money. Okay. Now in fractions, it's a good idea to make them add on to small units, because we're going to be working with the denominator. And the best way it works is, so Eva had $50. She used 3/5 of it to buy a jacket. How much money does she have left? I'm going to draw a bar that represents 5 units to represent the number of parts in my whole. So I'm going to, and actually that's why the graph paper works really well for fractions. Okay. And there's my 5 units. Now I want to go back and start labeling. So Eva had $50. So I know this whole thing is worth $50. All those units equal together $50 because she used 3/5 of the money to buy a jacket. And also the kids would, at this point, also have been exposed enough to fractions to know how to find 3/5. It would not be new to them. So then she used 3/5 of it to buy a jacket, so I need to put that into my bar. So I'm just going to put another bracket down here, and there's the 3/5 that she used. Now I'm going to go to the last part. How much money does she have left? So the question has to go for the 2 units that are remaining, because that's the 2/5 that she did not use to buy the jacket. There's my question mark. So now I'm going to actually figure out how much does she have left. Keeping in mind, that's my goal, is to get to that, figuring out what these 2 units could be equal to. So I know, and this is a step I put in. I don't expect students to do it, but I like to put down 5 units equals $50. All right. So can I figure out what 1 unit equals? It's similar to the last problem. $50 divided by 5, because I have 5 units. And each of these are equal parts. In fractions, we would know that every part is equal to each other. And you would get $10. Can I now easily figure out how much 2 units equals? $10 times 2. So this is now worth $20. So how much money does she have left? $20. Eva has $20 left. Now, of course, when if the children are starting to learn multiplication of fractions, they would end up doing 50 times 3/5, which equals 30, and they might do 50 minus 30, which equals 20, or 50 times 2/5, right? But at this point, we're not teaching them an algorithm. This is so important because this is the visual of that algorithm. So they have a visual representation they can fall back on when they say, okay, I'm just memorizing a rule. No, there's more to it. This is why it works, because we actually did the rule within the problem itself. Any questions on that? No? Okay, so I'd like you to try it on your own.
And then there's always more questions you can ask the children, right? Just to solidify understanding, like how much was the jacket? Like that sort of stuff, so that you keep talking about it.
Right. We would talk about, well, how much, and I could even say, well, how much is 3/5 of that amount? How do we know that we actually solved it? If you get 3/5, I'd figure out 30 plus 20 is 50, so I know I have all the parts that I have.
Well, isn't this how they check their answer? Because when I watch Helena doing even if she answers a question, then she has to show that it's right. Like she has to add or do whatever she needs to do to make sure that she came to the same amount, which is 50. So she kind of knows each fraction what it goes to.
So the question was, can you do a check? Absolutely. You could actually check it by figuring out what 3/5 is, add it to 2/5, and working back to 50. Absolutely. And that would be a great check to do. All right, so on your own, at the ice skating rink, 5/8 of the skaters were children. If there were 45 children at the ice skating rink, how many people were at the rink altogether? So this is going to be just one bar. Figure out the who and the what. And then my advice is draw a bar as long as the denominator with that many units in it to start off. And again, this is another problem that could easily be an algebraic equation also. to figure out where your question mark goes, what are they asking, and where does that 45 go? On top of how many units?
Shady, are you making the online people hold up their work?
No, but I am watching some of their faces when they.
Yeah.
Are they like shocked or not?
Most of them don't have their camera on.
Okay.
Just watching them talk through.
Okay.
Just like we all do.
Right. All right. So can I show the solution? Should I give you need another minute? Okay. You're doing great though. Everybody's really picking this up very easily.
And I did it right. The question is how many people altogether? Oh, 27, 72.
Well done. Yeah.
That's like 27 of the people who are adults.
Right, but that's how many altogether.
Yeah, you could see when my children are
While we're struggling at home.
Okay. And again, this would be from a problem that a fourth grader would experience.
Where it's just as frustrating when you're good at math because you see it differently than they do.
Exactly. And I could solve this algebraically very easily. But they don't know algebra, so how else can they get at it? All right. So do you have the who and the what? So you could put people at the skating rink people. I also have my bar set up where I know there's going to be 8 units to represent the number of parts in the whole. It says 5/8 were children if there were 45 children. So I know 5 of the units equals 45. And the question is, how many people are totally at the ice skating rink? Similar to the other problems, can you see how it would be really important to figure out what 1 unit equals? Now here I know only I don't know what the 8 units equals, do I? But I know what 5 units equals, right? So I know 5 units equals 45. Can I then figure out 1 unit equals? I could take 45 divided by 5 and get 9. So each one of these has to be 9. If you want to write them in, it's up to you. And then I know the question is, how many do 8 units equal? All of that. And I can just do 9 times 8 and get 72. There were 72 people at the rink altogether. Right? Obviously, algebraically, this might be the algebraic form. Right? No one likes to look at that. But you've had algebra, so I could do it this way also. But they're actually, I mean, that's what's so amazing about this strategy is that they are actually solving an algebraic equation,
Okay, so.
which eventually they would get to this part as they get older.
Right. So I followed all the steps. The one thing I found confusing about, I mean, eventually I was able to focus on one part of the question because when I put like 5 units is 45, but then I in my head I wanted to find where the 5/8 belongs on the bar. So I put that underneath, which is equal 5/8, and then I got stuck a little bit because I wanted to use the 5/8, but then this is the
Right.
part. So in order to solve this problem, you only have to use the 45. And
You
not
could.
the 5.
I could put the 5, I mean,
Right.
I could do this, right? So the question is, what do I do with the 5/8? I could do this. But then you have to decide, okay, which do I need? And yeah, you do have to make a decision at that point.
You know what I do? I actually color in the 5. So it's, so I know like that part is known.
That's a great suggestion, to color in.
So I can do that.
Right.
Just so I get an idea of what I'm solving
Right.
for.
Oh yeah, absolutely. Even
Yeah.
if you do that, it's
Yeah.
just like, but since we're trying to use all the numbers
Right.
given,
Right.
so in your head, like, how do I use the 5/8?
Right, and that's where students would have been exposed to enough of these types of problems to understand which one they would need. But you can see how if they have a mental representation in their head of what 5/8 or what 5/8 or 5/8 is a 45, that's pretty a powerful tool to to have. And this is the way they start. Otherwise, you end up teaching them an algorithm where they have to memorize it, but they don't know why it works. And I'm very big on, like, if you're going to teach an algorithm, they have to understand why it works the way it works, not just memorize a rule, because then it's easily forgettable. Okay, are you ready for one more? Okay, this would be a 4th or 5th grade problem, and I actually gave it to my 4th graders. They did reasonably well. They did reasonably well with talking it out. This is fairly complex, and it is multi-step. Okay, and there's only one who, so we're going to do one bar. And this is totally different than fractions. So Mrs. Sandora had $3,746 to spend on equipment for the school media room. She saved $650 for later purchases. She spends the rest on 12 monitors and some software. The monitors cost $205 each. How much did she spend on software? This is a mouthful, right? Even as an adult, you're like, what? Where do I start? So this is actually our last problem for now. I have like a challenge on the back page. But you can easily start by looking at number 2, identify the who and the what to start with, right? So we got to give, so who's the who and the what? Mrs. Sandora's money. Now, there is a lot in here, and we're going to be dividing this up in different parts. So I'm going to draw a really long bar model because there's all kinds of things going on that she's spending money on. So I'm going to make this long. Okay. And then we're going to start by rereading the problem and identifying what we need to do in our bar. So she has $3,746 to spend on equipment for the school. That's the entire bar, right? So does everyone see it? So I'm going to just, now I can put it off on the side if it's going to distract you, or I can put it on top. So I'll just put 3,746 here. And there's my bracket. Okay. Can you envision already what we're going to try to do? We're now going to try to divide our bar up to account for what's in the problem. So I use that up. She saved $650 for later supplies. So I'm just going to, now of the three, I want to make it proportional to 3,746. So I'm just going to say, there's the 650. I can even label it inside or outside, whichever is preferential. Okay. And then it says she spends the rest on 12 monitors and some software. Huh. All right, you're like, okay, I'm going to underline that because there's no numbers in that, but it looks like an important sentence. The monitors cost $205 each. How much does she spend on software? Huh. But I do know that she spends, I'm going to look at that number. The monitors cost $205. How many monitors does she buy? 12. So I can either draw 12 lines in here, or to have 12 sections, and the rest goes to software, right? So I know so maybe I'll do this. Software I don't know, do I?
That's the question.
That's the question. So I'm going to put software down here. And then I can divide this up into 12 parts, or sometimes also you can redraw it if you want to draw it larger here and make 12 parts. But I'm just going to draw my 12 parts. Put 11 lines in. 2, 3, 4, 5, 6, 7, 8, 9, 11. And I might adjust this a little bit because I'm...
How do you know that there are less software than monitors? Why did you assume that? I don't actually, and I'll find out at the end. It's just there actually could be, the software could be worth more than the monitors. I'm not sure yet. But it still gives me a very visual representation of what I'm looking for, because now I know how much did she spend on software. This is the question mark. But I forgot also I need to put back my 205. So I'm just going to put a little arrow here and say that that's $205. So I know each of these is $205. Yeah, and this is a messy problem. It is a messy problem. Okay. Can you now see the computation part of it? We're trying to now figure out how much, always look at that question mark. So what do we need to take out of the 3,746?
So what would be your first step? I'm curious. What would you do? Multiply? Right, so maybe I'll do 205, and the students would already know how to do this. I'm going to assume everybody knows the... Okay, so that's the monitors, and I like to put a label here because I want people to know it's monitors. Are you organized? Okay. Now, the second step. I figured out the monitors. What do you think I should do with that now? Because I still have to figure out what this is, this area right here.
I would write it up on your label so you don't forget what it is.
I'm sorry, say it again?
On your, where you have all your slashes, you write that in there.
Right, so I could do a bracket if I want and put 2,460.
And add to 650.
Right, it's interesting because I saw it differently, so I'm curious what you would do because I did it a different way. So I can work down, but I could work across. So what did you suggest, Wafa?
To add the 650.
To the 2,400? Yep, so I'm going to show a second step. Plus $650, right? Is that what you got? Did I add right?
3,110, yeah.
Yep. So you can see the room for error, like in all this. This is a very complicated problem.
And kids are so used to doing one step.
Right. So in
That's the answer.
fourth grade, we're doing anywhere from 2 to 5 step problems, and they love it. They're like, oh my gosh, more steps. Somehow it's more challenging to them. All right. So then I've got this. So I know that I'm going to put a little check mark. So I've taken care of the 650, and I've taken care of the monitors, right? So what do I do then with this amount? Can I subtract it from the total? Minus, right? And now you're left with, ta-da! The question. This is what's totally left, which has to equal the question mark, the software. So we'd say Mrs. Sandora spends $636 on software.
Oh, 636 is the answer? I did it, I just did it differently.
Nope. You could do it differently. I did it totally different. I actually started off by doing 3,746 minus 650.
That's what I did.
Right, and then I got $3,006, and that was what I thought was equal to the monitors plus software. And then I did the 205 times 12. And then I subtracted 3,000. Did I do that right? Mm-hmm. Yeah, 3,000. And then I subtracted the 2, and then I got the same answer, right?
Yeah.
Okay. So you can see there's multitude of strategies that you could use to solve this in different ways. This is
The hardest thing for kids to do is the regrouping with a 0. So the way you did it, you can, there are 2 zeros there.
right. So
This one's a little easier.
right, if you don't have regrouping. But the kids would have they should know that operation already by 4th and 5th grade. They should have mastered that. That is something that should have been mastered. So yes, they should be able to handle all the mathematics in this problem. All right. Any questions?
I mean, if you really think about this is a very complicated problem with sort of simple math.
Absolutely.
Like the math isn't
Right.
horrible. It's addition, subtraction, and then
Right.
in 2-digit multiplication. But it's the organization that's going to kill you if you can't
Right. So this would be
think it out.
This would be a problem I would use, after they've had a lot of exposure and practice, and almost as a challenge problem for students who want to take that on. This is not something mentally it would be fairly challenging for any student, 4th grader, to do this, to just write the numbers down without drawing a visual representation. of this.
Especially if it's multiple choice then, because they have all that work and they're like, well, which one is my answer?
Right, like what am I, I forgot what I'm actually looking for here.
I've been in some trainings where they'll actually ask the children before they draw the bar model to write the sentence with a blank in it
Yeah.
first.
In our younger
So
grades,
way
we
they
do that,
don't
yeah.
Stop. At once they've done one problem, they're like, wait, no, that's not my answer.
Right.
So that it just keeps reminding them of what they're solving for. And
That's very common in our younger grades. We will have them do that so they don't forget what the question is.
Right.
Because sometimes you can get so involved and then you don't know what number to even pick.
Right.
You've lost it.
you just stop.
And you just stop, exactly. The last problem I'm going to leave for you as a challenge problem. We do have packets of answers for you, so my suggestion is that you try it and then look at it. And I put challenge. And I have done this one with fourth graders before. But it's okay if you haven't graduated, from the second, third, fourth grade so far, so it's okay. At Shadyside Academy Junior School, 3/5 of the 570 students were fourth graders, and 2/3 of the remaining students were fifth graders. If the rest were third graders, how many third graders were there?
And it's time.
So, and actually, time is up. So I'm going to leave that for you to think about, to fuss with. What I suggest also always is contact your child's teacher. Sit down with them. Do some bar modeling with them. I'm happy to go over bar modeling with anybody also. To see that this is a really interesting tool to use for kids to get them started if they don't know intuitively how to do the problem. And some of these were some fairly challenging problems that involved algebra also at the same time. Does anybody have any more questions?
No, now I'm focused
No?
on this.
Are you doing the problem?
Yeah. Any questions online?
Now, did they get the answer? I don't know if they got the answer to this one
I
online.
don't think they did.
So for people who are online, if you'd like the answer, I can certainly email it to you.
So tell them to email you. Then.
Yes, email me at lbud@shadysideacademy.org, and I will forward you the actual answer key. I can. Oh boy, you're into it. It's a little addictive, isn't it? The whole bar modeling thing.
It is.
Once you start getting into it. So I hope people have a new understanding of bar modeling, its purpose, and how to actually draw the bar models, and how it leads into the computation part. So thank you for coming. And thanks for everybody online for watching.
Thank you, Lisa.
Oh, you're welcome. You're welcome.